Okay, so this is a case study that shows in context for a concrete problem. How can we integrate data from LTKB, which is the liver toxicity knowledge base, and also from DrugBank by using Edelweiss to help study the case of Rosiglitazone, which is a drug that has known liver toxicity. So the problem here that we're facing is a researcher wants to understand Rosiglitazone. Is it a safe drug to use? And the starting point is to look at LTKB data. And when we look at Rosiglitazone and LTKB, we find Rosiglitazone is marked as less deadly concern, so, i.e. less drug-induced liver injury. There's a drug which is structurally similar, Troglitazone, which is most deadly concern. So then we would like to understand more about the relationship between these two drugs. So why is it one of them is more dangerous than the other? What is their relationship? And how can we obtain more data? So Edelweiss can actually help you obtain more data about these drugs to help you maybe shed some light on this query. And here I performed an Edelweiss integration. So the green columns are the original columns available to me, and the blue columns I've obtained by using Edelweiss. So I started by getting the green columns from LTKB, and then by using Edelweiss, I discovered my PubChem columns, and then automatically, based on that PubChem identifier, I get the blue columns from DrugBank. So I get more information about these drugs. And then, DrugBank tells me a little bit about the toxicity and the absorption of these drugs. In addition to many other columns, there is more than maybe 10 or 20 columns we can potentially bring in from DrugBank when we have performed this integration. So I'm just suggesting 2 columns here. And we found that Troglitazone was withdrawn in year 2000 due to risk of hepatic toxicity. And we found something about the mechanism of action. So Troglitazone is an anti-diabetic agent, and there's a response to insulin. And we also found the pharmacology as well. So how does it act, and how is it being absorbed, and what's its relationship chemically to various small molecules and to various pathways. So this is information that we obtained from DrugBank when we had performed this integration. So that's one way that Edelweiss can help you obtain additional information given a concrete medical problem. And we found that Troglitazone is structurally similar, and Troglitazone is a failed drug that's been taken off the market. And this may suggest potential concerns for Rosiglitazone, and it may infirm further investigation that we're going to perform later on. And this helps you, if we look at the data life cycle for a concrete data set, and then initially the data is generated by performing an experiment or an assay, and then it's annotated, published, integrated, and then we can use the data and build upon it. And then it can be sent out to applications, to other studies, to derived data sets, and to whatnot. Edelweiss helps you address all of these early stage problems here in terms of annotation, publish, integration. First, we annotated the data set with linked data terms, then we published it in a data explorer, and then we integrated it with data from DrugBank. So all these data lifecycle problems can be addressed by Edelweiss as an integrated system. And I think this would add a lot of value for many people who have data in their labs, but they don't know how to use this data meaningfully in context.